Good evening, everyone, and this is 8 p.m. and welcome to this webinar. Thanks for joining it, and I see people are still joining. So let me start with a brief introduction. So this is London IT Contractors Group, and I hope you guys can see my screen. And so this group is actually we are IT contractors, and it's just to network with other contractors or any other people that are interested to become a contractors, or you just specialize as a as a career into IT contracting side. So uh, our the group is doing good. So we have a few members. They're quite active and they really participate with us. And this is by the all members. So feel free to kind of suggest us how we can improve the our events. And at the moment is we're trying to do three webinar events in a month and one face-to-face event. And here's a link to our website, and this is email, and you can send us and contact us anytime. So I'm sure you guys must have seen this website. So basically, what I am trying to do is if you can uh, fill up your details on that, because we're trying to get away from Meetup because it's very difficult using Meetup to send you a WebEx registration. So in the future is I'm just trying, if we can use this link, and so that we can actually send all the WebEx invitation through this website. That's the one part I'm trying to do. And second is this is another meetup is there, London.dev. This is another one of other organizers, David Jamal. He's helping us, so we're running the meetup with him, and feel free to join that as well. And you can have more interesting content on that side, and see more interesting events. And there's a ProxCon, there's a conference is running, and they are actually we are helping them. And this is another conference is in London, is happening in April, and I can send you the link. You guys can check this out as well. Now come to the agenda. So today webinar topic is this is a pragmatic functional refactoring with Java 8. It's quite exciting topic, and the speakers are here online with us, Richard and Rahul. I really like to thank them in advance for finding time for our group members, and I will make them presenters soon, and so that they can start it. So the next meetup for the group is happening in 23rd of Feb, and this is a face-to-face one, and we're doing in somewhere University of East Anglia is in Middlesex Street. So I hope to see you guys over there. And the next webinar event is on 16th of March, and this event is best practices with Git and Eclipse. So I'm looking forward to have your presence over there as well. And in the end is, I would like to apologize for the last week webinar event. We had some issue with GoToWebinar, and somehow we couldn't do that. We had to cancel that event at the last moment, but we will reschedule that event soon. Now I make Richard as a presenter, and he can actually start the talk. Thank you very much.
Hello, how's it going, everyone? Cool. Can you hear me okay, Harry?
Yep, again, yeah.
Can you also unmute Raoul's mic as well, the other person who's listening to Richard Warburton, so he can speak?
Okay, that's fine.
And make him a presenter as well.
Hi everyone.
Hi, Raoul. Fantastic, fantastic. Cool. Let's get going. Pragmatic functional refactoring with Java 8. My name is Richard Warburton.
and I'm Raoul over here in Cambridge.
Excellent, excellent. Cool. So we've obviously got a pretty buzzword compliant title here: pragmatic, functional, refactoring, Java 8, all sorts of stuff. So what are we actually going to be talking about? Well, a lot of people, when they hear the term functional programming, they think about this guy, or they fear they might turn into this guy. This guy is an academic. You can tell that because he's got a huge beard and he looks a bit unhappy. And this is what academics look like, isn't it, Raoul?
Yeah, don't all functional programmers have long beards, Richard?
Yeah, that is the stereotype. Whereas I think a lot more developers aren't necessarily so interested in the long beards and the looks of sorrow and all the rest of it. You know, they look a bit more like these guys, or okay, these are Lego models, but they look a bit more like real people. They're interested in getting their job done, and they want to see what makes their lives easier. So the goal of this talk is to try and explain some of the concepts of functional programming and show how they can be used to solve everyday real-world programming problems and how they can make your life easier. And in order to do that, we're going to be coming through about 4 different topics. Okay? So we're going to be talking about first-class functions. Again, this kind of fancy, buzzwordy academic name, but there's some interesting ideas there, some use that we can have there. And then we'll talk about currying, which has nothing to do with food. Then we'll have a couple of food pictures as we go through. And then immutability and optional data types are the other things we'll be talking about. So, first-class functions.
So, Richard, we've got a business going on here, and I'm going to be the software developer here that needs to produce quality code that is bug-free and flexible. You're going to be really annoying customer, the annoying user, okay?
Fantastic. I can definitely be an annoying customer. I can totally play that role. So what we've done is we've been really fortunate here, and we've picked up Oracle as a client in our hypothetical consulting business. That's right. We've done the almost impossible, managed to get some money out of Oracle. So Raoul, what I want to know for my kind of management reporting is if you've got some invoices, how do you find the invoices which are sourced from Oracle?
Well, Richard, so that's a pretty straightforward task. We're going to declare a method here that's going to take a list of invoices. And we'll iterate through each invoice one by one, check that the customer is Oracle. If it is, we'll add that invoice to an accumulator. We do that until we've iterated through the whole list of invoices, and we can then return the result. Nice and easy. Can you pay me?
I can pay you. I can definitely pay you if we picked up Oracle as a customer. But suppose we've got another customer coming in. Let's say that we've picked up, say, Facebook as a customer. What would we have to do there to perhaps have the option of sorting by different customers?
Well, Richard, one approach would be to duplicate the method and just rename it funny voice from Facebook. But obviously, we'll have some code duplication here. We'll have to maintain 2 separate methods that are doing more or less the same thing. It's just that the condition here is different. So I'm going to abstract this requirement change. I'm going to abstract the customer here, introduce a new parameter to the method to take the new customer in consideration. Nice and easy.
Fantastic. So you've abstracted over the customer by making it a parameter. That's good. Less boilerplate, sounds good. Less code to maintain over time. But what if we go one step further? What if we want to find invoices with, like, say, a different title in the name? Like, say, we want to check if there's consulting or training in the invoice name.
Well, in that case, it's slightly more tricky because you're asking for a sort of different property. So I don't have much choice but to duplicate this method that contains the same iteration logic, but we'll introduce a different parameter here, a different requirement change, which is a suffix. And we'll use this parameter here in the body of the method to make sure that the invoice ends with that specific suffix. Does that sound reasonable to you, Richard?
Well, it kind of feels like we've got a lot of duplicate code here, doesn't it? So we've got something similar to the previous thing, but with just one line of code change. We've got a single if statement. Could we have one method that maybe combines both of them?
Richard, I'm glad you asked. You know, as a true software engineer, we all strive for abstraction and code reuse. So I just know the right trick here. Let's combine those two methods into one. Let's definitely introduce a flag here so we can pick whether we're interested in the customer or the suffix. You know, less code duplication here, Richard. Isn't that beautiful?
Well, not exactly. We've got this kind of horrible Boolean flag going on, and we've got the flag saying if it's true, we do the customer check. If it's false, we do the invoice suffix check. Looks a bit ugly to me, doesn't it? Don't you think that's ugly?
Yeah, so for full disclaimer here, obviously we don't encourage anyone to use this kind of method here. It makes your code harder to understand, but also it doesn't scale to other requirement change and other properties that you like to do the selection on the invoice. So obviously this is a really bad way of solving the problem. Let's take our software.
Sorry, it doesn't let us combine things either, right? We can't talk about a filter about the customer and the suffix at the same time. We can't combine these things.
Indeed, so it's really limited. So let's take a software engineering hat here and, you know, let's find a way to model this selection criteria that we're talking about. So what we're really trying to do here is, given invoice, we like to model the idea that we're applying a condition on the invoice. So something that takes invoice and returns a Boolean. And in mathematical terminology, this is referred to as a predicate. A predicate from one element that will test this element and return a Boolean. So this is an interface that is available now in Java 8. So we'll just use this interface called predicate. And with this in hand, we can start refactoring our find invoice method here. So our find invoice method is going to take a predicate as an argument. So those are going to be different ways of how we'd like to check an invoice. We can update the body of the method here to test the invoice with that predicate as an argument. So this is really neat now, because if you got a new requirement change that comes in, you can model that requirement through a predicate object.
Fantastic. So that means that we could, for example, implement that interface with a class like Facebook Training that gives us checks the customer's Facebook and the invoices related to training. But this still looks a little bit verbose, doesn't it, Raoul? We've got to implement a whole class here every time we want to just change this one line of code. So we end up with 1, 2, 3, 4, 5 lines of boilerplate for one line of business logic. Is that really the best we can do?
Richard, I thought you were paying me by the number of lines of code that I'm writing. You know, why are you complaining here? But I understand your point. The code here is really quite verbose, and you know, we're making use of a new class that we have to declare here, even we instantiate only once. So there are better ways of doing things. So one way of doing that in Java 8 is, well, let's model selection of an invoice through a regular method that has a name, a meaningful name here that is matching the business problem. In this case, we want to check if the invoice is from Oracle. So I'm going to have a method here called isOracleInvoice that takes the invoice and just check if it's actually coming from Oracle. I may have a different requirement which checks that the invoice is training related, so has a suffix training. What you can do now in Java 8 is to say, well, I've got this method here that's already modeling a predicate. It's taking an invoice and returning a Boolean. Why don't we just reuse this method directly? You can do that through a method reference. So we're using this method here as a value. We're injecting it as a second argument to find invoices.
Fantastic. That looks much, much cleaner. But I also keep on hearing about these lambda expression things. How can they help us solve this problem as well?
Fantastic question. So in the previous slide, we could use a method reference because we had a method available already and declared, and we could just reuse its name to pass it as an argument. But sometimes what you really want is just a little throwaway code that's just going to do the work as well. So we can use a lambda expression here. It's a bit like a method, if you will, but with no name, and you're still able to pass it around just like a method reference. So here, as you can see, we've got a lambda expression that will take an invoice, and the body of this lambda expression here will just check that invoice customer is Oracle. And we can do a similar trick here to check that the invoice is training. So that's a new feature that was introduced in Java 8. And it's really a great way to sort of represent a little piece of code that you like to pass around to a method, in this case, find invoices.
Awesome, looks really neat. So first-class functions, as we said, it's really a very kind of common topic that we see in functional programming. And actually, it's really related to this topic of a function object that we see in kind of object-oriented programming. Also, the command pattern is another thing that kind of has a similar concept here. All we mean with first-class functions is the ability to use a function like it's a regular value, pass it as an argument to a method, or store it in a variable. And we've shown here how it can help us cope with requirement changes. And this is Raoul's favorite feature in Java 8, right? Method references.
It is indeed. I'm a big fan because, a lot of concepts that we hear in functional programming, first-class function might sound like something really scary. But actually, it turns out that's something we already make use of in object-oriented programming languages with other design patterns. It's just that now in Java 8, you have a more concise way of doing things. So the story is actually first-class function. You can do even more than that. It's not just about passing a function as an argument to a method. What we'll look at be doing now is actually how can you compose different functions together, different methods together to create a richer program. So the analogy here is, if you think of a function as Lego blocks, and we can't see you guys right now, but, I'm sure some of you are still playing with Legos. I do personally, and Richard is still a big fan as well. We all love Legos. But the really beauty that you get with
Legos for years. Massive fan of Lego. Wish I was a child again so I could.
I hear that Minecraft these days is the digital Lego version. But the general idea with Legos is actually, as a piece on its own, it's not that interesting. You can't do much with it. But once you start putting the pieces together, once you start combining them, then you can actually create some really great architecture and some really great projects. And that's something quite similar that we can do with function by composing them. I'm just going to show you a couple of examples of how this can be achieved. So let's come back to our invoice domain. So let's say we already have a predicate which checks that an invoice is from Facebook. And then we've got another one that checks that actually the invoice is from training. What we'd like to solve now is how can we check that an invoice is both from Facebook and is related to training? Well, if we take traditional Java, then we might have to create a new class here that again provides an implementation for that, or a new method. But what you can do by composing function is say, well, I already have those two functions available. Why don't I just compose them together to create a new one that models this new predicate? And this can be done using this AND method here. So we're saying, well, is the Facebook invoice and is it related to training? And AND here is taking another predicate. And the result of this will be a new predicate that you can then pass on to the filter. We can do something similar if we'd like to check that actually the invoice is from Facebook or it's related to Google. We can use two separate methods, compose them together to create the richer one. So we're making use of code reuse here.
But Raoul, how's that working under the hood? Those AND things on functions, are they some kind of...
Yeah, so it looks quite complex, but actually it's really fairly simple. Predicate is an interface. So when we've got an instance of a predicate, we get an object out, and we're always able to call methods on objects. That's the way Java works. So if we look up the implementation of the predicate interface in Java 8, you'll see that not only it supports an abstract method called test, but supports two default methods. If you're not familiar with default methods, don't worry. It's just a way to have implementation code inside interfaces. So that's something I was also introduced in Java 8. But if you look at the implementation of this method, you can see in the case of AND, it takes a predicate as an argument, and all it's doing is to return a new predicate as a result. And this predicate here tests the element with the current predicate, the current instance, and then checks it with the one passed as an argument. We can do a similar trick here with the OR method by checking the predicate with the current element, or also checking it with the one passed as an argument. And that's sort of the beauty that you get with first-class functions. Not only are you able to pass lambdas and methods and function as an argument, you can also return them by composing functions together. So another example of how you can apply function composition is by creating sort of so-called happen filtered pattern here. So we sort of like to compose different methods together. They're not just predicates, there might be other things. So in this case here, we've got a sort of an email, and we like to be able to maybe add a header to an email, do some check spelling, add a signature to the email. But different mail clients may want to be able to combine those operations differently. Maybe you just want to do the check spelling, or maybe you like to add a header and the check spelling and the signature. So you'd like to sort of create a sort of pipelines of processing. So in this case, we're going to model a processing object here through just a simple method. So add a header, takes the email in, and will produce a new email out. And similar for check spelling and signature. We can make use of this method here called and then available in the function interface, which lets you compose two functions together. And what that's going to do is to take the output of the first function, for example, add a header, and give that as an input to the following function in the pipeline, for example, add signature in this case. And by doing this, you can compose multiple methods together and create richer pipelines of operations.
Fantastic. So it sounds like first-class functions are a pretty useful concept there. But what about currying? Now, when you first hear currying, you might be thinking of food, but it's actually related to code. So throughout this section, we're going to have a little running example of a conversion function. So this is when we're modeling this kind of linear relationship between inputs and outputs. We've got an amount we want to convert, and then we have a factor we're going to convert it by. So that's like which we multiply by a base. So kind of y equals mx plus c. So for example, by using a factor of 1.8 and a base of 32, we can convert between Celsius and Fahrenheit. And in fact, we can use this conversion function. Yeah, so we can convert from Celsius to Fahrenheit with different temperatures. Or we could also convert currencies, dollars into pounds. I've heard the cause of the financial crisis was the fact that we just had a hard-coded concept for the dollar-pound crisis. Have you heard that theory, Raoul?
Yeah, we all know that it's really fantastic to use doubles for money-related applications.
For money-related things as well, yeah. Fantastic. But something where it does work out well again is the conversion between kilometers and miles, so distance conversions. Here a little bit more complicated factor, 0.62137, but it works for different types of conversions here.
Richard.
So, yeah.
Richard, do we really have to plug in those arguments every time? For example, when you were sort of converting the temperature here, you had to plug in those arguments again. Is that really necessary?
Exactly, good question. So we had to plug in those same arguments again and again when we wanted to run the function multiple times. And this kind of motivates a couple of different questions we might want to ask ourselves. Firstly, there's the question of abstraction. So how do we write something that operates over different conversion functions, regardless of what the parameters are there? And secondly, there's the question of reuse. How do we use the conversion function in different places in our code without having to plug those hard-coded constants in, as you mentioned? So this is where we get onto our topic of currying. My favorite curry is the thali. Now, thalis are these kind of big curries that have all sorts of little dishes associated with them. And you can think of currying a bit in a similar way from a programming perspective. Currying is the act of taking out one function that eats all of its arguments in one monolithic step and breaking it out so that they take each argument one at a time. Fantastic.
I'm really getting hooked
So,
on extended time.
yeah. So in the currying or conversion function, what we might want to do is rewrite it. So originally we had one function that took 3 parameters. Now we're going to take a function that takes the factor and the base. There are things which are, say, related to a specific type of conversion, and returns a double unary operator. Again, a bit of a fanciful name here, but a double unary operator is just a function that takes one double as an argument and returns a double as a result. So that would be the amount is its argument, and it multiplies that amount by the factor and adds the base. So it does just the same thing. Now, this means that we can build functions just from these input values. So we've got our convert function, and we pass in 1.8 as the factor and 32 as the base, so our temperature conversions, and we get back our double unary operator, convert from Celsius to Fahrenheit. We call applies double on 10, and we get our result back again. So we're able to reuse this function in multiple places in our code. Which also brings us on to partial application. This is the eating of the curry. Now these people in this photograph are not doing a very good job of eating their curry. For a start, they don't look as happy as someone should be if they're eating a nice hearty curry. And secondly, they're drinking wine, which is not a great thing to drink with curry. And thirdly, they've got an unopened party cracker in the middle of the table, suggesting they've not finished doing their crackers before they got to food. So, you know, partial application is the eating of the curried function. So, in our partial application examples here, we pass in the arguments for centigrade to Fahrenheit, 1.8 and 32, or for currency conversion, 0.6 and 0, or for kilometers to miles, 0.62137 again, and 0 is the base factor. So we've applied some of the arguments to the function, but not all of them, and got a new function back in return. Now, we were saying that, you know, something that developers are really keen on is the concept of abstraction. And we could have written a very, very abstract currying function. What I've done here is I've written one specifically that works with ints. So it takes an int binary operator as its argument. So that's something that takes 2 ints, thus binary, as arguments, and then returns an int as a result. And it returns an int function onto int binary operator. Okay, sounds a bit confusing. But what that's really doing is saying, take the first argument, and then return a function that takes another argument, and then applies it to the function. So here's a general way of writing currying. There isn't built-in support for this in the Java language, but you can write it like this. Cool. And then here's a very, very simple usage example of our currying function, just applying to add to add 2 numbers together, our first number and our second number. So we apply the first argument, 1, and then we apply the second argument, 2, and obviously the result's 3. Nice and simple. Cool. So where would you want to use this kind of thing? Well, there's a few different example use cases for currying. For a start, if you've got very kind of large arguments, you can use it a bit like the builder pattern, where you incrementally apply some of the arguments to this one method and break up the call so you can kind of reuse it a little bit. And then, of course, there's also what the functional programming team call combinator libraries. So you get these libraries that do things like parsing strings or templating HTML files and the rest of it. And they build up these very general reusable components from just individual functions which can be partially applied. For example, you've got something that will parse any number of things, and you say partially apply it to, say, a white space character, and then you get a function back that can parse any number of white space characters. And you build up a bigger, more complicated program from this. Cool. So in summary, currying is about splitting up a monolithic block of arguments to a function so they can be applied individually individually. And partial application is this function eating some of its arguments and returning a new function. So, immutability. Immutability is all the rage right now, isn't it, Raoul? What's immutability all about?
Immutability is all the rage indeed, Richard. You may hear quite a lot in conjunction with functional programming. And as software engineers, we always striving to reduce the scope for bugs that arise in our code base, and that's the sort of things that we'll be talking about in the next two sections. So to start with, we'll talk about mutable objects, and to really give an example of what mutable objects are about, we'll talk about train journeys. So as we all know, in England, trains always arrive on time, so that's just great. So let's model a train journey here with a price and with an onwards journey. So maybe I might want to get from Cambridge to London and then London to Heathrow. So I could model that with train journey. What mutable objects are all about is that once you've instantiated one of them, you're able to change its state later on. And typically we can do that through setter method. So for example here, we might be able to change the price of a train journey, or we might be able to set the onward journey to something else. But that's not the only way of modeling data. You can also make use of what we call immutable object. And that's the idea that once you've instantiated a class and you've got an object, you're not able to change its state anymore. So typically that's done through adding final fields to prevent reassignment, and you have to ensure that the titles are immutable themselves. It's a transitive property. You want to ensure that this class is final to prevent extension as well. But instead of having setters that are changing the state, what you can do is to add methods which are actually creating a new object. So as you saw in the previous slide, you could see a with price method or a with a new onward journey. What that's doing, it's actually to create a new train journey object out. Well, so using those two different approaches, let's see how we can actually join up two train journeys together. The first thing we're going to do is to take the immutable approach from Cambridge to London, and there's another journey here going from London to Heathrow. And I'd just like to chain this up into one big journey. Well, from a visual point of view, what you want to do is just to modify the onward journey ahead for the starting one and just link it up with the continuation journey. So what we're doing here is to change the state of the first object so it links to the continuation journey. And that's called a mutable approach. And let's see in code how we can do that. So here's a potential implementation for this. So we'll take a starting journey and a continuation journey. Then we iterate through all the onward journeys until we reach null. Once we reach null, we know that we've reached the end of the starting journey. We can link that up with the continuation journey by modifying its state. So quite nice and simple, classic Java code. Well, let's look at a potential interesting issue here. It's sort of it makes sense to expect that once you link a starting journey and a continuation journey, and you do it again, you'd sort of expect to have the same result out. Well, so here we've got a little code here that's going to visit the second journey. So it's just going to print out all the prices for each journey, so from Cambridge to London to Heathrow. What do you think will happen? Well, actually, this code would produce a Stack Overflow error, so really nasty. A program would crash at runtime. The reason for that is, after the first call to link, we've modified the state of the starting journey, and someone else in the code might be making use of the starting journey and not expecting the change. Once you call this method again, what happens is that you actually have to iterate through all the onward journey, reach the end, which is now the continuation journey, and link that up with continuation itself. So we sort of introduce a cycle here in training journeys. And as we'd like to print the prices one by one, we end up iterating forever. And if that's done recursively, that would produce a Stack Overflow errors. So mutable immutability really can lead to some really nasty bugs when you're not expecting the object that you're passing around to different parts of the program to be changed. Well, you're in luck because there's a better way of doing things, a way that reduces the scope for bugs. It's called the sort of functional style way, or the immutable way. And that's the idea that instead of modifying an object that is coming from the caller, is that we actually will create a copy. We'll create a copy that's completely independent, and we can then link that copy with the continuation journey, which means the caller here has something completely independent to the initial starting journey that they were using. So how can we actually implement something like that? Because it sounds pretty good. Well, we can make use of quite a sort of really neat way of expressing this problem recursively. So we'll start with the starting journey. Obviously, if it's null, it means there's nothing we can link into, so we'll just return directly the continuation journey. Otherwise, we're just going to recursively copy the starting journey and link that up with the continuation journey. So recursively, we can copy all the onward journey starting at the start. And finally, once we reach null, we can append the continuation journey. So immutability is not a new topic in Java. That's something that we've been making use of for years. If you think about the integer class or the string class, they're all immutable. But it's something that's really coming back now because we realize the benefits of immutability in terms of reducing the scope for bugs. Java 8, the new date and time API, is completely immutable by design. It's also a related topic in the domain-driven design with value classes. And that's a topic that we're going to see again in Java 10 with the introduction of value types. Other programming languages support that as well. If you're interested in enforcing immutability in your code base, there's various tools that you can make use of. The mutability detector is one of them, and findbugs can often give you some feedback on that use as well. Bear in mind that the final keyword only bans reassignment, which means that you need to ensure that the type of your fields also have to be immutable. For example, just having a final array field in the class is not good enough because you can always change the content of that array, so that array is mutable. And also an interesting project, JSR 308 now lets you have annotation on types. So there's a whole bunch of annotation like not null or immutable, which you can use, and tools can inspect those types as well to give you feedback. Now, there's no such thing as a free lunch. Making use of immutability can increase memory allocation because you have to create those copies of objects. So that may be an issue, but if those objects are short-lived, then they'll be easily garbage collected, so that's not always a problem. It makes things a little bit harder to model as well. If you got a hierarchy that's quite deeply nested and you want to change an object inside that hierarchy, then you might have to copy the whole hierarchy. So often that can make things a little bit more complicated. But we still encourage you to make use of immutability. And in the case that you need to make changes, keep it localized with some small, simple mutable objects. So that covers immutability. So it's a good way to reduce the scope for bugs and prevent nasty bugs. Now we're going to talk about a related topic, which is also about reducing the scope for bugs, called the optional data types. And I heard that's something that Richard particularly enjoyed before going to the pub, isn't it?
Optional data types before going to the pub? No idea. Okay, optional data types. You know, what they're really trying to solve here is this our friend here, this null pointer
So I think we just lost Richard. I will take over. And let's talk about null pointer exceptions. You know, some people say that null pointer exceptions are actually, they should be the new hello world example in Java, because you always see them as the first thing you see in a Java application. Well, what can we do to prevent those null pointer exceptions? So I think we lost Richard, so I can't actually change the slide. Let's see. Just bear with us for 1 minute if we can fix this issue here. And I will take over the slides. That'd be great. Fantastic. I can't actually change the slides myself, so we have a little issue here. All right, so I don't know if one of the organizers is still online, but I'm unable to change the slide unless I'm given some sort of permission.
So how do you want to do it, Rob? Shall I make you presenter?
If you could make me the presenter, then I'll be able to carry on the webinar myself.
So, okay, let me see. So I make you presenter.
Fantastic.
Okay. Cheers.
So could you let me know if you're seeing my screen or some slides?
Yeah, I can see your screen, yeah.
Can you see this beautiful slide with some code?
Yeah, guys, raise your hand. At least I can see that, yeah.
Perfect. So I can take over at this stage. Thank you very much.
Yeah, all good. Thank you.
Great. So guys, we're back in the game. Fantastic. I think Richard just had his virtual machine crash, obviously. Classic. So I will take over for now. So here's some simple code that we like to resolve, right? So let's say we've got a person and we like to be able to find the insurance name of his car. Typically how we can solve that here is through a simple query. Get a person, get its car, get insurance, get the name. The question is, where is the null pointer exception? We've got a really cool wally here. I'm wondering where's the null pointer exception, because it always hides. So just like null pointer exceptions, always hiding. Well, it turns out that you could have a null pointer exception here at every single stage of those method calls, right? If person was null, you get a null pointer exception. If get car was returning null, you get a null pointer exception. If get insurance was returning null, obviously you could get another null pointer exception, which is really nasty. So what can we do to prevent that kind of thing? Well, let's use defensive checking. We're going to explicitly check that a person is not null. If it's null, we'll extract the car. Then if the car is not null, we're going to extract the insurance. If the insurance is not null, then we'll extract the name of the insurance. So this code really is the pyramid of doom. You know, it's looking more like an algorithm as opposed to a simple traversal query. So this is really verbose, error-prone, and unreadable. Well, there's good news. There's a new data type that was introduced in Java 8, and this data type is also available in many programming languages called Optional. And what it is, it's really modeling a single value container. It's a container that may have a value or may not have a value. So either contains one or it is empty. And the benefit of using Optional is that you get explicit modeling. So when you model, you can make something optional. You know that it may or may not have a value. So that leads to better maintainability. But even better is that to extract values inside an optional, you need to go through its API. So it's a lot less error-prone to deal with. You need to explicitly override the optional to check if there is or isn't a value. So let's look at how we can adopt optional here to reduce the scope for null pointer exceptions in our code. Let's first update our domain here. So we'll ensure that a person may or may not have a car. So personally, living in Cambridge, I don't need a car. I can just walk around everywhere. This is really great. A car may or may not have an insurance, so it's an optional insurance. Now, I know what you're going to say. In England, you definitely need an insurance, but I was talking to one of my Brazilian friends and was telling him, well, in Brazil, you know, it's not always compulsory to have an insurance. So let's just say it's optional. But once you've signed up to have an insurance, it definitely has a name. So we're making that explicit in our model as well. Fantastic. So using this new model that is more explicit, how can we actually solve our initial problem, which is given a person, we want to find the insurance of the car. So I will introduce a method here called Optional.map, which basically says, given an optional object, I will apply a function to the value inside the optional. So in this case here, let's say we pass a method reference to the insurance name. What we get out is an optional of a string because getName returns a string. Okay, so that's a way, that's a pattern to extract information from an optional object. So let's try and use this method here to solve a problem. So given a person, we're gonna extract the car. So we'll use map here and pass a method reference to getCar. Then we like to next extract the insurance, so we'll pass getInsurance here. And finally, we'll like to extract the name, so we'll pass a method reference to the insurance name. Unfortunately here, this code doesn't compile. And the problem that we've got here is that getCar in our refactored model returns an optional of a car. The next method here is expecting a car object to extract the insurance, but the object is optional. So we get a sort of nasty optional of an optional of a car that is returned, and that's not really helpful. Well, in those situations, we need to make use of a famous dog here. So for those of you who are familiar with Reddit and Hacker News, this is the meme that you might often see. So flat, such map, much optional. We need to make use of a different method here called flatMap. The idea with flatMap here is that if you see yourself in a situation where you've got nested optionals, flatMap will flatten this nested optional into one single box. So in the case of map, if we pass car get insurance, we'll get an optional of an insurance out. But if you use flatMap instead, we'll just get an optional of an insurance, which is easier to work with. So the only thing we need to do here to create this traversal query in a type-safe way is to make use of flatMap. So we'll start with a person. We'll write this person inside an optional object. And then, because getCar returns an optional, we'll call flatMap. So we extract the car, so we'll have an optional of the car. Next, we want to extract the insurance. But the method getInsurance now also returns an optional object. So that's why we have to call flatMap again. What we get out is an optional of an insurance. And finally, we only call it map here because we want to extract the name, and getName returns a string, not an optional. So that's why we call map. And finally here, if at any point any of those methods here returns an empty optional, then we can have a default value here, unknown. So that's sort of the power that you can get using the optional objects. Not only do you get more explicit modeling, but also you can use the API here to guide you to a traversal query in a type-safe way without having to add those defensive null checks that are really error-prone that you might forget to do as well. So a little comment on naming. Flatmap and map, you might feel that actually those are not really very readable method names. They're not really particularly useful. And the reason for that is if you've used the Stream API in Java 8, the Stream API already supports the method map and flatmap with a very similar pattern. So you could think of an optional object as a stream that has one element or is empty. So just for consistency, that's why the optional here makes use of those method names. So if you're already familiar with the Stream API, it provides you with an easy migration path to use optionals because you're already familiar with that pattern. So there's a little bit of discussion that's been going on in the past couple of years about whether you should or shouldn't use optional objects in fields, and maybe you should just reserve that to public methods.
Controversial topic, I hear.
Ah, we've got Richard back in the game.
Hello.
So Richard, what do you think?
It's the use of optional fields, almost as controversial as Windows' decision to restart on me in the middle of the webinar there.
What do you think, Richard? What's the controversy about?
The controversy on optional fields. Well, sometimes optional has some advantages when being used in fields, and sometimes it has some disadvantages. So on pros, we've got the idea that we're explicitly modeling the fact that something can be optional or not. So it's in the type, it's type safe, we can see it, it's well documented. That's a nice property. And if we've got getters, we can just call get, and we can return a reference, an optional background on the other side. And it also gives us this null safe access property. So it can be useful in fields. On the cons, there's more indirection and garbage collection overhead, because you're doing a bit more pointer chasing, but that could be solved in Java 10. On the other downside, not every library understands optional, and some libraries require serializable fields. And optional as a class is not serializable because it's a bit simpler to implement that way. So they make it serializable. So there's pros and cons to it. Some people hate it, some people love it. We think it depends upon the situation. Handing back over to you, Raoul.
Indeed. So as you can see, optional is a great new tool for your toolbox here, and consistent use of optional can reduce the scope for errors, and specifically does not enable point exceptions. So to conclude this sort of webinar here, we've talked about 4 topics from functional programming, and as you can see, they're actually really useful from an object-oriented programming perspective as well. We're all striving to write code that is more maintainable, but also that reduces the scope for bugs. So in the summary, first-class function, it's a great way to cope for requirement changes when you can model the requirement change through a method and you can just pass it around. It's sort of new behavior. Currying is a way to split the parameters of a function to reuse its code logic. Immutability is a way to reduce the scope for bugs. And finally, optional data types here reduce the null checking boilerplate, and you can use the API here to guide you in traversal query and prevent bugs. So Richard, what's this picture about here?
Well, nowadays, we've kind of moved from a situation where functional programming was for academics. We've understood what the ideas are when we're talking about functional programming. And, we can now think about it as being a topic that we can use usefully. So we can be real people, but with a little bit of functional programming language. We've moved to a middle ground here. Are you there, Raoul?
Yeah. So Richard, if you're interested in hearing a bit more about us, Richard here has written some great books and also is a Pluralsight author. So if you're interested in courses related to testing in generic, do check out his profile on Pluralsight. He's written a book called Java 8 Lambdas if you're interested in finding more about Java 8. I've myself written a book on Java 8 called Java 8 in Action, so that's the one on the left-hand side here, which you can also read. But more importantly, both of us, we run a training company called iteratedlearning.com, and we provide in-house training courses in Java. So we've got Java Bootcamp that lets you master software development, so learn about testing, generics, collections. And we'll now hand over to Harry and take any questions if anyone has any question for us.
Thanks a lot, guys. It was really very knowledgeable webinar, and there's a lot of points you guys have touched, and I'm sure the group members must have enjoyed it. So I just leave the audience to ask any questions. So please raise your hand if you have any questions you want to ask. If any one of you want to ask a question, or you can chat me if you feel comfortable that way, then I can ask presenters. Okay, so I have a question actually. Uh, when you write this lambda expression code, like, so how do you debug that kind of code in terms of like when you're debugging, like, so how do you step into that kind of a um, operations, like when you're using a stream and on using a filter kind of thing? So you have any inputs on that, guys? My question is clear. Is it? Shall I come
Yeah,
again?
your question. So I'll take over this question, Richard. Feel free to jump in. Um, so lambda expression is, it's a piece of code, and you're able to step through this code as well. So recent IDEs like IntelliJ 15 will let you provide support to breakpoint on a specific lambda expression. So that's something you can do already. With the Stream API, things are slightly more complicated due of the implementation of streams are lazy, so the operation lazy, so that adds a bit of complication. But you're able already to debug through lambda expression, set a breakpoint, and get some sort of contextual information. One of the issues maybe with lambda expressions is in terms of stack traces, because lambda expressions are anonymous, then the sort of compiler has to figure out a way to tell you what's an entry point or what's the lambda expression specifically that might have caused a sort of exception. So stack traces are slightly different now because you've got this anonymous name. Richard, I don't know if you want to add anything to that.
I think generally that's a very good answer that covers a lot of the things. The only other thing I will point to specifically is if they're debugging streams code, there's a method on there called peek that lets you print out or log individual elements which a stream is going over without doing anything else with them. So peek on stream is also quite a useful tool in the debugging toolkit.
Okay. There's a one question from Ricardo, and he's saying, can Java support pattern matching?
At the moment, there's no built-in support for pattern matching in the language. I don't know if it might be added in future, in a future version maybe. Well, I think it would be a nice improvement, but there's certainly no support at the moment.
Okay. And any other questions, guys? You can ask in this questions tab. So looks like there's no questions coming up. So I just conclude this webinar, and thanks a lot, guys, for this session. And pretty much it was again very useful, and I'm looking forward to have more topics from you guys around Java 8. And let me know if you want to send any information to group members. Any of the any courses are coming up, so we can announce to the group members. And again, thanks everyone for joining this webinar, and have a pleasant evening, and take care. Bye. Good night.
Thanks for hosting us.
Yeah. Cheers. Thank you, guys. Bye.
Bye.
Bye.